Hello everyone, I am Dr. Janavi Chakrabarti, Assistant Professor, Department of Mathematics, Bardhaman College of Engineering. Today in this video, I am going to explain the Simpson's one-third rule, which is useful in estimating definite integrals if the function is complex or set of tabulated values are given or if it is difficult to obtain exact solution of definite integrals. Now let us see what is Simpson's one-third rule. Simpson's one-third rule for estimating definite integrals of the form I equal to integration a to b f of x dx uses three equally spaced points to approximate the area under the curve. By definite integrals, we know that it is the area under the curve f of x in between two fixed points. Here it is a and b, and this area under the curve is represented by this integration a to b f of x dx. In numerical integration, what we do, we will divide this a and b into n subintervals and we will approximate the integration. Now look at this figure. Here we have 6 subintervals: x0, x1, x1, x2, x2, x3, x3, x4, x4, x5, x5, x6. And these subintervals x0, x1, x1, x2, we are taking 3 points: p0, p1, p2. So this Simpson's one-third rule uses 3 equally spaced points. It uses these 3 points, then x2, x3, x4, p2, p3, p4, then next is x4, x5, x6. This can be approximated by quadratic polynomial or second order polynomial. Here the integrand is approximated by a second order polynomial or quadratic polynomial. If n equal to 1, then we have 2 points x0, x1, then that is approximated by first order polynomial. Here n equal to 2, so we need 3 points and it is approximated by second order polynomial. Also, this number of subintervals in Simpson's one-third rule must be even. If it is odd, then we cannot use Simpson's one-third rule. This Simpson's one-third rule can be obtained from Newton-Cotes quadrature formula or general quadrature formula by putting n equal to 2 in it. So this is the Newton-Cotes quadrature formula. Here if we put n equal to 2, we will get the Simpson's one-third rule. So the Simpson's one-third rule is given by integration x0 to xn f of x dx h by 3 y0 plus yn plus 4 into y1 plus y3 plus y5 plus so on plus yn minus 1 plus 2 into y2 plus y4 plus y6 plus so on yn minus 2. Look at this point. These are odd numbers and these are even numbers. So we can say this is equal to h by 3 first term plus last term plus 4 into sum of odd terms plus 2 into sum of even terms. So what we can say, h by 3 sum of first and last term plus 4 into sum of odd terms plus 2 into sum of even terms. Now let us see how to derive the Simpson's one-third rule from Newton-Cotes quadrature formula or general quadrature formula. First of all, let us write the Newton-Cotes quadrature formula. By Newton-Cotes quadrature formula, we have integration x0 to xn f of x dx is equal to nh y0 plus n by 2 first forward difference of y0 plus n by 12 2n minus 3 second forward difference of y0 plus n by 24 n minus 2 whole square third forward difference of y0 plus so on, which is equation number 1. Now put n equal to 2 in 1 and look at this. N equal to 2 means we have 3 points. N equal to 2, that means we have 3 points x0, x1 and x2. What are the corresponding y values? y0, y1 and y2. So this will be first forward difference of y0 and this is first forward difference of y1. And what we will get? Second forward difference of y0. So now what we will do here, we will take the curve through 3 points x0, y0, x1, y1 and x2, y2. Taking the curve y equal to f of x through x0, y0, x1, y1 and x2, y2 as a polynomial of second order so that higher order differences are 0. Therefore, third forward difference of y0, fourth forward difference of y0, and so on, all will be 0. From here also we can say the same. Now what we will do? We will put n equal to 2 here. Therefore 1 becomes integration x0 to x2 f of x dx. x2 means x0 plus 2h f of x dx. So we have nh, that will be 2h y0 plus n by 2, that will be 2 by 2. First forward difference of y0 plus n by 12, 2 by 12, 2n minus 3, that means 2 into 2 minus 3. Second forward difference of y0 plus 2 into 24, n minus 2, 2 minus 2 whole square. Third forward difference of y0. Okay, so what we have? 2h y0 plus first forward difference of y0 plus 1 by 6. 4 minus 3, this is 1. Second forward difference of y0. And what will be this one? This one will be 2 minus 2, this is 0. So this is 0. Now we have 2h y0. First forward difference of y0, you can write it as y1 minus y0 plus 1 by 6. This one can be written as y2 minus 2y1 plus y0. 2h y0 will be cancelled out, y1 plus 1 by 6 y2 minus 1 by 3 y1 plus 1 by 6 y0. So we will get 2h 1 minus 1 by 3 y1 plus 1 by 6 y2 plus y0. This will be 2h 2 by 3 y1 plus 1 by 6 y2 plus y0. Now you take 1 by 3 outside. If we take 1 by 3 outside and multiply 2 inside. So first one it will be 4y1, and here if we multiply 1 by 3, so it will come out h by 3 y0 plus 4y1 plus y2. Therefore x0 to x2 f of x dx, we have got h by 3 y0 plus 4y1 plus y2. Similarly, x2 to x4 f of x dx, we will get h by 3 y2 plus 4y3 plus y4. Then we will get x4 to x6 f of x dx equal to h by 3 y4 plus 4 into y5 plus y6 and so on xn minus 2 to xn f of x dx. This will be h by 3 yn minus 2 plus 4 into yn minus 1 plus yn. We know that integrals are additive over subintervals. So we will add all these integrals. Adding all these integrals, we get integration x0 to x2 f of x dx plus integration x2 to x4 f of x dx plus integration x4 to x6 f of x dx plus so on plus integration xn minus 2 to xn f of x dx, and this is equal to h by 3 y0 plus 4y1 plus y2 plus h by 3 y2 plus 4y3 plus y4. Third term h by 3 y4 plus 4y5 plus y6 plus so on plus last term h by 3 yn minus 2 plus 4yn minus 1 plus yn. Now look at this side. This side we have some definite integrals, and we can write this as integration x0 to xn f of x dx is equal to h by 3 y0 plus 4y1 plus y2 plus y2 plus 4y3 plus y4 plus y4 plus 4y5 plus y6 plus so on plus yn minus 2 plus 4yn minus 1 plus yn. Now we can write it as h by 3 y0 plus last term we can write it together yn plus we can take 4 common from these terms 4y1, 4y3, 4y5, 4yn minus 1, y1, y3, y5 plus so on yn minus 1 plus this y2 plus y2, y4 plus y4, y6 plus y6 and so on. We can write it as 2 into y2 plus y4 plus y6 plus so on yn minus 2. So this is the required Simpson's 1/3 rule, which is given by integration x naught to xn f of x dx is equal to h by 3 first term plus last term plus 4 into sum of the odd terms plus 2 into sum of the even terms. Now let us evaluate definite integrals using Simpson's 1/3 rule. Now look at this problem. Here we need to evaluate integration 0 to 2 e power minus x square dx using Simpson's 1/3 rule, and h is given to you. Here a equal to 0, b equal to 2 and h equal to 0.25. Therefore, number of subintervals n will be equal to b minus a by h. So it will be 2 minus 0 by 0.25. It will be 8. Also, f of x is equal to e power minus x square. Now what we need to do? We need to form a table of x and y values. The values of x and y equal to f of x are given below. We need to form a table here. X points. What are the x points? It is starting from 0, 0.25. The next one we will get 0.50, 0.75, 1, 1.25, 1.50, 1.75 and last point is 2. As we need to find e power minus x square values, so first of all let us find x square. So these are the values for x square. Using calculator you can find these values. Then we will find y equal to e power minus x square using calculator. Now we will put these values in Simpson's 1/3 rule. Therefore, by Simpson's 1/3 rule we have integration x naught to xn f of x dx is equal to h by 3 y naught plus yn plus 4 into y1, y3, y5 plus so on yn minus 1 plus 2 into y2 plus y4 plus y6 plus so on yn minus 2. Here we have y naught, y1, y2, y3, y4, y5, y6, y7 and y8. So we can write x naught to x8 f of x dx is equal to h by 3 y naught plus y8 plus 4 into y1, y3, y5 and y7 plus 2 into y2 plus y4 plus y6. Therefore, x naught is 0 to 1. F of x e power minus x square dx is equal to h is 0.25 by 3 y naught plus y8. Y naught is 1 plus y8 is 0.0183 plus 4 into y1 is 0.9394 plus y3 is 0.5698 plus 0.2096 plus 0.0468 plus 2 into sum of the even terms. 2 into even terms are 0.7788 plus 0.3679 plus 0.1054. If you compute this value using calculator, you will get 0.88207, which is the required answer. Let us now look at this problem where we need to evaluate integration 0 to 1, 1 by 1 plus x dx using Simpson's 1/3 rule. So here neither h nor n is mentioned. So what we will do here, a equal to 0, b equal to 1. As for Simpson's 1/3 rule, the number of subintervals must be even. So let us take number of subintervals as 6. Let us divide 0, 1 into n equal to 6 subintervals, each of which h equal to b minus a by n. That means 1 by 6. Also, y equal to f of x is equal to 1 by 1 plus x. Now we need to make a table for x and y values. The values of x and y are given below. X values are starting from 0. As h is 1 by 6, x1 will be 1 by 6, x2 will be 2 by 6, x3 will be 3 by 6, x4 will be 4 by 6, x5 will be 5 by 6, x6 will be 6 by 6, which is 1. This is how we are dividing the interval 0, 1. Now let us compute y values. Y is 1 plus 1 by x. If you put 0, it will be 1. And for these values, you can use calculator and you will get these values. This is y0, this is y1, this is y2, y3, y4, y5 and y6. Now let us use the Simpson's 1/3 rule. Therefore, by Simpson's 1/3 rule, we have integration x0 to xn f of x dx is equal to h by 3 y0 plus yn plus 4 into y1, y3, y5 and so on yn minus 1 plus 2 into y2 plus y4 plus y6 plus so on yn minus 2. As here we have till x6. So x0 to x6 f of x dx is equal to h by 3 y0 plus y6 plus 4 into y1 plus y3 plus y5 plus 2 into y2 plus y4. Now let us put the values. We will get h is 1 by 6, 1 by 6 into 3, y0 plus y6, y0 is 1 plus 0.5 plus 4 into y1 is 0.8571 plus y3 0.6666 plus y5 0.5454 plus 2 into y2 plus y4 0.75 plus 0.6. Now if you compute this using calculator, you will get 0.6931, which is the required answer. So this is how we need to evaluate definite integrals using Simpson's 1/3 rule. Thank you.